Hi guys, in this video I go over exceptions. I explain what exceptions are and why they are useful. Then I'll demonstrate how we can handle exceptions with a try-catch block and how we can extend the try-catch block to handle multiple exceptions. I'll use a common example to read in two integers from the console and perform division on those integers. First, I need an object of type scanner that listens to system.in. I'll import the scanner class, and then I'll prompt the user to enter the first integer. I'll store that integer in a variable named a. Next, I prompt for a second integer, and I'll store that integer in a variable named b. Then I'll perform division by dividing a by b, and finally I output the result. Now I run the program and test it with some normal input. For example, 15 divided by 5. This will give me 3. So this program works fine. However, let me try this again by using 0 as the denominator. Now we can see an exception. An exception occurred in the thread main because of a division by 0. So what are exceptions? An exception is an unforeseen event during the execution of a program that interrupts the normal program flow. So here the normal flow would be performing division by A by B. Now with B being 0, this normal program flow cannot be executed. And so an exception is thrown. This cannot be executed because division by 0 is undefined. So the program doesn't know how to handle it. So it throws an exception, and the exception causes the termination of that program. So the program simply ends. We can see it no longer executed the statement to output the result. So why are exceptions useful? Exceptions are useful because they allow us to respond to these type of events, and then we can handle them appropriately. For example, if an arithmetic exception occurs, we can output a message to the user that the input was invalid. Or if another example, if a network connection fails, we could maybe catch that exception and try a second time. Now let's see how we can handle this exception with a try-catch block. A try-catch block always wraps code that we want to try to execute, but we catch an exception that could occur. For example, here I could wrap these two lines in a try-catch block, and I catch this arithmetic exception. Now, try is a keyword. Then we have a code block here between these two braces. This is the code that will try to execute statement by statement. If everything works well, we just skip the catch block here and continue afterwards. However, if an exception is thrown that matches the type in the catch block, it will be caught here, and then the code block in this catch block will be executed. What we can do here is output a message, error division by 0. Now running this again with 15 and say 3, it will output 5. So this is the regular flow of the program. It performs division and it outputs the result. Now if I put a breakpoint here and I run this again, it will hit the breakpoint. After I enter the values, I enter 15 and 0. So we can see it hit the breakpoint here. Now if I step one line forward, we can see it actually skipped this line because the exception was thrown. It matches it to the one defined here. This one matched, so it executes the statements in this catch block. And here I'd output it now, error division by 0. The program no longer crashes due to the exception because the exception is caught and properly handled. Now the try catch block, you always want to keep it as small as possible, but you want to have it big enough that it covers the exception in an appropriate way. For example, this statement here, it wouldn't make sense to have it after the catch block because there's simply no way that we can execute it and properly show the right results. So it is tightly coupled to the statement before. This needs to be executed in order for this to make sense. So it makes sense to have both of these in a try catch block. Now let's try something else. Let's say I run this again and I enter 3 spelled out, and here we go, I cannot answer anything else. Now I got a input mismatch exception, and this one again caused the program to terminate. Now what I can do is I could wrap this in a try catch block, right? I could do try and then catch this exception here, or what I can do, I can wrap this into a single try catch block and say I want to catch everything, and now I want to catch 2 types of exceptions, so I catch multiple exceptions. I want to catch the arithmetic exception, and I want to catch the input mismatch exception. I can do this with a single vertical slash mismatch exception, and now this catch block will handle both of these exceptions. It will handle the arithmetic exception and the input mismatch exception. Now if I try to run this and I enter, for example, 3, it will output the message because it entered the catch block. So the error message is not really relevant. But we can see it caught this exception here, and if I perform division by 0, 3 and 0, it will also enter and execute the statements. So in some cases, you want to handle multiple exceptions. You can do this with a single vertical slash. We can also separate these two. So I can, like in this case, it doesn't really make sense. I want to have a different error message. So I want to handle these 2 exceptions differently. So I take this one out and simply add a second catch block. And here for this one, I show error must enter integers as digits. So not spelled out. And now when I run this, depending what exception is thrown, if I spell a number out, I will get this message, must enter integers as digits. And this we can see also, it executed this line, it executed the line here. This is where it failed, where the exception was thrown. So it skipped all the remaining statements in the block, try to match it to the arithmetic exception type. This didn't match, so it tries the next one, input mismatch exception. This one matched, and so it entered the block here and outputted this message. Now, this is how you can handle exceptions. I hope you enjoyed this video. Thank you for watching.